Guys, we are going to look at Krebs cycle. Now remember, the end product of glycolysis, it is pyruvate, which is a triose sugar, and in this case it's going to enter the matrix of the mitochondria, but we have several reactions which take place. But we shall need hydrogen carriers, and in this case we are going to use NAD and FAD. NAD is nicotidamine adenine dinucleotide, and FAD is flavine adenine dinucleotide. So what is going to take place? This process of Krebs cycle, it is one of aerobic respiration. In this case, we are going to use oxygen and shall form carbon dioxide. And remember, we have two processes involved during aerobic respiration, that is Krebs cycle and electron transport system. However, we don't see the exact use of oxygen during Krebs cycle, but we are going to see it in electron transport system. But before we get inside the matrix of the mitochondrion or the mitochondria, there are some reactions which take place to prepare this product, which is called pyruvate. But remember, we have two molecules from glycolysis. So what is going to happen? Number one is going to be decarboxylation. In this case, remember, this is a triose sugar. We are going to remove one carbon from pyruvate. And when we remove this carbon from pyruvate, it is going to go as carbon dioxide. When it goes as carbon dioxide, it means we are reducing the number of carbons from pyruvate to come to acetyl group, and acetyl group has two carbons. But before we form acetyl, there is dehydrogenation which takes place using enzyme dehydrogenase, and oxidized NAD is going to form reduced NAD. But the acetyl group cannot move direct to the matrix of the mitochondrion. We have a carrier we are calling coenzyme A. Coenzyme A is going to combine with acetyl group to form acetyl coenzyme A, which is going to carry it to the mitochondria, and the mitochondria is going to deposit it in the matrix. Then coenzyme A can go back to pick other molecules of acetyl. So the beginning sugar or salt in the matrix of the mitochondrion, we are going to use oxaloacetate or oxaloacetic acid, which is a 4-carbon sugar. When it combines with acetyl, remember this is 4 carbon, this is 2 carbon, it's going to form a 6-carbon sugar compound, which is called citric acid or citrate. That's why the cycle is also called citric acid cycle. So we are forming 6 carbons here. So what is going to happen next to our citrate? We are having decarboxylation, whereby we are going to move 1 carbon from the citrate. Then we shall have also dehydrogenation, and the hydrogens are going to be given to oxidized NAD to form reduced NAD. And we are going to form alpha-ketoglutarate, which is a 5-carbon sugar. So from alpha-ketoglutarate back to oxaloacetate, we have very many intermediates. We are going to focus mainly on 2 sugar intermediates or sugar compounds. So from alpha-ketoglutarate, we shall have decarboxylation to reduce the number of carbons from it. So we are going to form succinate or succinic acid, which is having 4 carbons. But before, we have also dehydrogenation, and the hydrogens are going to be taken by NAD. Then we are having ATP formed directly for the cycle or for the Krebs cycle. Remember, we are using 2 molecules of pyruvate, so it means even acetyl, we are having 2 molecules of acetyl coenzyme A. It means even this cycle is going to be trice. Let me say we are going to form 2 ATPs here. But this ATP formed here, it is as a result of substrate level phosphorylation, in that we are going to get ADP and it's going to form ATP, not as it happens in the electron transport system. That one which happens in the electron transport system is called oxidative phosphorylation. This one is called substrate level phosphorylation. So we shall end up forming succinic acid or succinate, which is a 4-carbon sugar. Then from succinic acid to malate, we shall have just dehydrogenation. We shall not have any more decarboxylation because our beginning sugar was a 4-carbon sugar. So we shall have dehydrogenation, but at this time the hydrogens are handed over to oxidized FAD, not to NAD. And remember, reduced FAD forms 2 ATP during oxidative phosphorylation, and reduced NAD forms a total of 3 ATP. And we shall form malate. Then to convert it to oxaloacetate, we shall have further dehydrogenation using enzyme dehydrogenase, and the hydrogens are going to be given to oxidized NAD and shall form reduced NAD. So let's go through the summary. So we shall form 2 molecules of carbon dioxide. So because we are having two molecules of pyruvate, for each molecule of pyruvate will form 1 carbon dioxide. So since there are 2 shall form 2 molecules, and we are having dehydrogenation, and the hydrogens are given to NAD. It means we are going to have 2 molecules of reduced NAD being formed, and 1 NAD forms 3 ATP. So 2 times 3 we shall form 6 ATP here, ATP molecules, which will be formed during oxidative phosphorylation. And the entire cycle we shall form 2 molecules of ATP as a result of substrate level phosphorylation. Then we shall form 4 molecules of carbon dioxide, because we have the first decarboxylation here from citrate to alpha ketoglutarate, then another one from alpha ketoglutarate to succinate. So since we are having 2 molecules of acetyl coenzyme A, it means we are forming 4 molecules of carbon dioxide. Then we form 6 molecules of reduced NAD. One is here, another one is here, another one is here. So it means since the molecules of acetyl are 2, it means we shall form 6 molecules of NAD. And 1 NAD we said produces 3 ATP, so 6 times 3 we are forming 18 molecules of ATP, and we shall form 2 molecules of reduced fat, and we are going to form 4 ATP out of them during oxidative phosphorylation. And in our bodies we are forming a total of 40 ATP. But remember, we use 2 ATP molecules during glycolysis, during the step we are calling phosphorylation. So we shall end up subtracting the 40 minus 2, so we shall end up forming 38 net ATP in our body. So this is the summary for glycolysis as we covered earlier. But to talk about these hydrogen carriers in details, we are going to focus mainly on oxidative phosphorylation during electron transport system, as we are going to cover it in the next series.